Let's do the maths, guys. All right, so we want to do number 49 out of 17.1. We'd like to establish, is this line, x is 5 plus 7t, y is 4 plus 3t, and z is minus 3 minus 2t. So parallel to the plane, 2x minus 3y plus 5z is 5. So what?
Do we care about the constants?
Good. Which constants do I care about and which ones don't I? Which thing, what are you saying constants?
On the plane don't matter.
Yeah, the 5, 4, 3 don't matter.
Okay, good. What things don't matter? I do not care about this 5 here. And I do not care about this 5, this 4, or that 3. Is that true?
Yeah, that's just
Yeah, because those just determine like where it is.
That's not,
Space.
yeah,
Very
those,
true, like-
we don't need
Good.
to.
Yeah. This is just a kind of,
up and down.
yeah, like up and down almost. And these are also just the initial point, right? What am I really asking? Is the line parallel to the plane? What do I need to look
Are
at?
the slopes the same?
Are the slopes the same?
Could we, since it's
Super close, yeah. So this thing definitely has a slope, right? What's the slope of this line?
7, 3, -2.
Yeah, so,
Okay, so the slope of this line is 7, 3, -2. Okay.
So compared
And-
to the gradient? No.
slope of that one's 2, -3, and 5.
Ah, so this thing you're reading off, 2, -3, 5, is the
Normal vector.
normal vector. Right?
Don't they have to be multiples of each other to be the same?
Normal vector.
So what does the normal vector do with the plane?
Make it perpendicular.
It's perpendicular.
So if it's
those two are
perpendicular to the
perpendicular,
slope, that's parallel to the plane.
Yeah, good. Right? Here I have something that's the line slope, right? I'm wondering, is the line slope parallel to the plane, but the plane kind of has two slopes, right? So it's easier to go to the normal vector and ask, is this slope perpendicular to that? How do you test if something's perpendicular?
Dot and see if it equals 0.
Dot it, see if it's equal to 0.
And I don't.
So they could have asked, instead of is the line parallel to the plane, they could have asked, is
Normal vector.
2, -3, 5 dot 7, 3, -2 equal to 0?
No.
No.
No? What did you get? 14 minus 9 minus 10? Not 0.
Yeah.
Perfect. No. Cool. Is it perpendicular to the plane?
No.
No.
No, the dot product.
Yeah, dot product has to be 0.
If it was perpendicular to the plane, it would be parallel to the normal vector.
Perfect, yeah.
So we would cross them and see if we got.
Yeah, is this vector parallel to that one?
So cross it.
Yeah, we could cross them and set them equal to, and wonder if that's the 0 vector, right? Another option is we could wonder, is this thing a scalar multiple of that? If it was, right? What's the relationship between, how do I get from 2 to 7? I need to multiply by 7 halves, right?
Yeah.
Okay, then I could just check, does that scalar work for the other
No.
coordinates?
No, not at all.
That one's times -1, right? And this one's times
-2/5.
-2/5. Yeah, none of them work. Right? They're all different scalar multiples.
So hit the plane somewhere.
Yeah, so this thing hits the
Yeah.
plane somewhere and it's not perpendicular to it.
Okay.
When we dotted those two vectors, see if they're 0. Isn't that testing to see if they're perpendicular?
It is. It's testing to see if they're perpendicular. And the reason I'm wondering are they perpendicular is I've got a plane, right? I know this vector that sticks straight out of it.
Oh, okay.
And I'm looking for a line that's
Yeah.
parallel to it.
Yeah.
So if the line's parallel to it, right, that really means it's going to look something like crap,
And we
this, right?
Yeah.
With the same.
Which
line.
means that it's going to be perpendicular to the normal vector too.
And then crossing it would tell us if it's.
Yeah, crossing it will tell us if it's parallel. Or we could just inspect and see if it's a scale.
So, hold on. So dotting it is parallel?
Dotting is perpendicular.
Okay. If
But
it's-
here I'm checking for perpendicular to something that's perpendicular to the
Okay, I
point.
see.
That's why they asked you this question. There's too many perpendiculars in it and it's a little tricky. Cool?
And we know if we dot product it, if it's 0, we know it's perpendicular.
Yeah.
If we cross product, how do we know it's perpendicular? 0?
Cross products tell you about parallel.
You would have to actually. measure
Remember there's that
the
area of the
line.
parallelogram thing
Yeah.
with cross products? When two vectors are parallel, right? Then the parallelogram looks like this.
So no matter what, when you cross product them, they are parallel?
If the cross product is the 0 vector, they're parallel.
Okay.
So that would be phrased, if V cross W is 0, then V is lambda W for some lambda.
That we don't care about. What we do care about.
It depends on what you want to do with it. Usually you don't
Yeah.
care, right, because it's
Okay.
parallel. If you care about like, where do these things point or something, that maybe would make a difference. Cool?